How is it going? Welcome to Mirchi Tech YouTube channel. It's been a while I posted any video in this YouTube channel, but today I started a new series on the dependency injection specifically for Python. But since from now I will try to post videos regularly. So today let's jump to the topic dependency injection. Dependency injection is used across all software world. It is used in MNCs. It can be used in startups as well. Like if you are not using dependency injection, that means you must be lacking. Like you must be dealing with the main. You must be having tough time to maintain classes. So let's talk about whenever we have a component as in, like, let's say if we have a monolithic service, like it's a single component that's handling all the traffic. So it, let's say when they're monolithic as well, if you have a business logic, you cannot really run entire business logic in the traditional way, like as in like you cannot maintain fit in a single class. You definitely need to break it down into multiple classes and build relationships among classes to fit it better. Otherwise, like you will be having the maintenance nightmare. So even with the microservices as well, even if you try to break down your entire architecture into multiple microservices with less responsibilities, like you still want to use the relationship among classes. Like maybe you can start with a single class, but over the time when the business logic expands, you definitely have to move to the multiple classes, and you need to somehow maintain relationship among classes. So in order to do it, to maintain the relationship, we can in the traditional way we can, if a, let's say if there is a class A that is depending on class B, class A itself can create the object with either within its constructor or at the runtime. Like maybe if there is a method called handle or process or anything, like it can create that object. So in the traditional way, we are, if a class A has dependency on class B, class A itself is responsible to create the object of class B. But there are some problems with this approach. Like let's go through the each of the problems. So before going to the problems directly, let's understand what is a dependency. So let's say here in this example, like class A has dependency on class B. Class B is called as dependency because it's a kind of free object, and class B is very tightly coupled with class A. Sorry, class A is very tightly coupled with class B because class A requires class B to process. So class B here is called as dependency, and class A is called as dependent. So in the example, we have an order service. Let's take an example of a class order service that needs to process the customer orders. So in order to process the customer orders, it requires three different classes. Basically it's taking help from three different classes so that it can delegate some of the responsibilities to these classes. It is depending on the SMTP email service to send the confirmation mails, and a Stripe payment processor class to do the payments, and it relying on a MySQL database class. Treat this as a class, not the actual database itself. Maybe this class will have some logic to interact with the database. So order service is relying on these three classes to process the customer orders. So let's see how it's doing. Like we have a class diagram. So think of it like in traditional way without using any dependency injection. It's creating the objects within its constructor itself. Like order service is a class with as a part of the order service constructor. Let's treat this init as a kind of constructor. It's a Python specific, but in any language, like we have the same. Like think of we are creating the objects of dependencies directly as a part of constructor. So in the traditional way we are doing this is not dependency injection. So that's what it is. So the problem is like tight coupling. So what happens is, like if you see this, right, like let's say SMTP email service, like here we are kind of hard coding the hard coding the parameters like host name and port number, similarly in database where if hard coding the URL and port, if we have to change in future, we really have to change everything. It's a added unnecessarily tight coupling. Order service is very coupled with this. So we right now we cannot change it. So let's assume tomorrow we may want to change this domain, like host name to something else. So we definitely have to make code change in order service only to make this code change. So it's added unnecessarily coupling. So that is problem one. And the second problem is concrete implementations. So if you see this same example, right, it created the classes objects directly. These are the concrete classes itself. So let's say these are very tightly coupled with these services. So let's say if we want in future, if we want to change the email provider to something else, it's a very tightly coupled. Here we have to change in constructor only. Or in let's say tomorrow we want to do the payment with PayPal, again we have to tweak the constructor itself to process it. And similarly, let's say if we want to feature in we want to post to PostgreSQL database instead of this MySQL database class. So there also we need to tweak this constructor only. So it's not scalable, not maintainable for long term, because it created the dependencies itself. That is another problem. And then one more problem is testing becomes a bottleneck here. So let's say we have the original classes order service, and then we have a test class called a test order service. So we have to test the business logic, like how it works, right? So right now, if you have to write unit test for the order service, we cannot mark the dependencies right away, because all the dependencies are created as a part of constructor. So it will be nightmare to do the testing here, because whenever we create this order service instance, it will create the original classes instead of marks. So of course there are ways to handle these scenarios as well, but that will make the unit testing complex. So yeah, and there is one more problem as well, that is basically the configuration duplication. So think of this example. We have the MySQL database is a class. Let's say this is a common class. The MySQL database class is responsible to handle any DB operation with the actual MySQL DB. So right now we just talked about the order service in the example. So let's say there are few other classes as well, like customer service, payment service, shipping service. So with the traditional approach, what ends up happening is, we will end up creating these objects directly as part of the constructor itself. Like order service will create a copy of MySQL database. Similarly, customer service will create a copy of the MySQL database, and similarly all other classes as well will create it. So there are two problems one is code duplication, how to construct the object will become complex. So let's assume MySQL database this class will take 3 parameters to create the class, and let's say tomorrow we have to pass the fourth parameter. We had to introduce a new fourth parameter. That means we have to change the definitions at 4 different places. This is one problem. And one more problem is, let's say this is a database, right? Database, we can actually use the same object, basically the singleton object, in all classes instead of creating multiple places, because there is no point, right? Ultimately, the request has to go through this class only. So it doesn't sound good to create multiple objects, whereas we could have fit with one class, because if we end up creating multiple objects, it will just eat up the memory, and it will bloat up the memory, and it will create unnecessary noise. So to have the memory efficiency, we have to create the singleton class only for some classes. For example, database, we need to have singleton class only. So these are the problems. So let's see how we can solve with the dependency injection concept. So the concept is whenever we are introducing a new class, we will define the dependencies, and also when defining the dependency, we never directly refer to the concrete classes. Instead we will refer to the interfaces or abstract classes. So let's think of this. Let's say there are three interfaces here: I email scraper service, I payment processor, I database. So let's assume there are three interfaces, and there are some concrete classes. There is SMTP email service, SendGrid email service. These two are concrete classes of email service, and similarly Stripe payment, PayPal payment are concrete classes of I payment processor. MySQL database and PostgreSQL database are the two concrete classes of iDatabase. So maybe today we may have the only one concrete classes dependency, but it's always preferable to directly refer to the interfaces as the dependency in your class definition itself, because we can't predict tomorrow. Like maybe let's say if you are using MySQL today, it may work fine and you may be okay, but what if MySQL suddenly raised the bill, and they if they demand so much money, so you don't want to stick to that, right? Like you may want to have alternative plans as well to move to the other databases, if that makes sense. So that's why we must maintain our class dependencies referring to the interfaces, so that it will be easier for us to maintain as well. So this is one thing. Like we can in our class, as you can see in here, we were referring to the interfaces only as dependencies, and it's our responsibility, like the client's responsibility. Let's say if I am using this order service, right, it's my responsibility to provide the dependencies, what kind of classes I require. Let's assume out of them, like I may require a combination of for email I may want to send email grid service. So it's my responsibility to create this class first and inject this dependency while constructing this order service object. And similarly, if I want PostgreSQL database, like it's my responsibility to pass this dependency when constructing this order service responsibility. As a class, it doesn't need to be very tightly coupled with actual implementations. So it needs to depend on the abstractions only. So that's the part one. And second thing is, like if we were able to segregate the dependencies referring to the interfaces, right, like we can easily do the testing as well. So in this example, the same example, I have the order service. These are depending on the iPayment gateway and iEmail service. These are the interfaces. So what I could probably do is I can create two new classes. These are the mark classes where I can mark the dependencies. Instead of making the calls to the network, I can mark it. Maybe I can add log statements, or I can, if I have to store something, I can store in the in-memory itself. So in-memory variables itself. So I have the control to create my own concrete mark classes. And while constructing this order service object, I can pass the marked concrete instances as dependencies instead of the original ones. You can see the Python example here. I can briefly walk through. So we are creating the mark instances first. Basically, treat them as a concrete class instances, and then we are, while creating the order service instance, we are passing those marks only. Testing will become easier if we are able to structure our classes referring to the interfaces only over concrete classes. And it's there is one more thing we can benefit is centralized configuration. So far we are having the implementations as a constructors in traditional way. With these dependency injections, what generally preferable is you maintain your classes referring to the interfaces, and the definitions you can maintain at one place or one folder where you can have multiple layers. You can provide the definitions, so it's easier. So in the previous example where I called out MySQL database require new parameter, so think of the entire interface itself may require it's either an interface require a new parameter, or only MySQL may require a new parameter. So in that case, we can, if we have a common place where we provide all the object definitions, so there we can just introduce the new configuration, and that will be passed to all classes wherever that is being used. So that will help, like if we can maintain configurations in a, configurations are nothing but the class definitions itself. So that's it. And yeah, the benefits, those are the benefits we can get from dependency injection. So yeah, I will just quickly walk through this comparison table. Testing will become easier with dependency injection. Flexibility, like we can have swap implementations, like if you can quickly migrate from MySQL database class to the PostgreSQL database class, if we just always refer to the interfaces over concrete classes. Configuration, I would rephrase it as class definitions that can be centralized in one place. Coupling, it will be loose coupled in with the dependency injection. Reusability, like it can be reused across all, the same classes can use all. And maintainability, we can, it follows the design principles, solid design principles. So yeah, it makes sense. Testability will become easier. Extensibility, yeah, we can, whenever there is a new requirement, we can just create a newer version of the interface and we can proceed. Yeah, so even extensibility also will become easier with dependency injection. Yeah, I think that's it. So yeah, I just want to highlight this quote: classes should focus on what they do, not how their dependencies. So whenever you are designing a class, you need to focus on what is your logic to do. You always need to think of the interfaces only, not the how they are created, how they are constructed, and all. Like it's the other's responsibility. Like as a person of the, as a owner of the class, your responsibility is focus on the business logic, not the object creation itself. Of course, it's the person who is using your class, it's his responsibility to organize the things better, like to provide the whatever implementation he requires. Like it's up to him, like whether he wants to provide the create the provide the object definition as a singleton, or if he is kind of duplicating, it's up to him. But as a class owner, you need to structure in such a way that you should focus on business logic, and you should not focusing on creating your dependencies yourself. They need to come from outside. So that's it. And yeah, there are as many as frameworks in multiple languages. So that dependency injection concept is very language agnostic. Like it's the core concept lies be the same. It's just the how you get benefited will be different. In Java, there are frameworks like Spring and Google Goose who will provide dependency injection. In Python, like injector and a dependency injector are two different modules which will help us to do the dependency injection better. Yeah, I think that's it. The end of the video. So in the next series, I will try to first focus on injector package, and then we talk about how we can define the classes. Like in the next session, I will focus on the classes and I will walk you through the examples itself. Yeah, thank you, Tigers, for joining. Have a good day. Bye.